Okay, let's go through the proof for number 6. We'll try to do 6 and 7, and at least on the video in case you're struggling with them. Can't do everything on a video, so hope you're not getting your hopes up for that, because it just can never happen. There's just not enough time. If we look at this proof on page 232 in section 6.4, they say A is parallel to B. We know that's true because it's up here. It was what was given. Remember, the first thing you always put is given in a proof. And it's going to, that's always going to go on line 1. All right, now, angle 1 and angle 3, why is that true? That's because they're corresponding angles, and corresponding angles are congruent. Okay? Now, they say angle 2 and 3 are supplementary. Why is that true? Well, they're a linear pair. They are a linear pair. Their outside rays make a line, so they're supplementary. 4 says that if you add them together, they're 180. Well, isn't that what supplementary means, that if you add two things, they're equal to 180? That's just what the definition of supplementary is. See, they're giving you all the steps here. They're making this proof easy. You're just trying to follow it and add the reasons. Now, if you look at 5, the statement above it said if you add 2 and 3, you get 80. Now they're saying if you add 2 and 1, you get 180. How can they do this? How can they switch from 3 to 1? Look back up here at step number 2. Step number 2, they said they were equal. So if they're equal, we can take 3 out and stick 1 in its place. We can just substitute it. So for step 5, that's just substitution. If you remember, when you're doing a proof, once you get the things rolling, a lot of times you're just looking at steps above it to see why, they listed some things that you're going to use in steps that come after it, okay? So now, on step 5, if 2 and 1, if you add them and you get 180, then they're supplementary, because the reason that's true is just that two angles that add to 180 degrees are supplementary. That's just the definition of supplementary. Up here on the 4, we could have put supplementary angles add to 180 if we wanted to. But, supplementaries add to 180, and if they add to 180, they're supplementary. So, anyway, so we're finished with that one already. That one went really quick. Problem number 7, they're wanting us to prove corollary 3, that if in a plane, if a line is perpendicular to one of two parallel lines, it is also perpendicular to the other. This is actually pretty easy to prove. If you kind of follow the proof, statement 1, they say C is perpendicular to A. Well, that was given, wasn't it? So you're just writing the reasons in over here in the right column. I'm just going to write the statements down so it makes it easier to follow on the video. Statement 2 says angle 1 is a right angle. Why is that true? Well, if C is perpendicular to A, perpendicular lines form right angles, don't they? So that's what we're going to write right here. Okay. Statement 3 says that angle 1 is equal to 90 degrees. Why is that true? Well, the reason that's true is a right angle is equal to 90 degrees. All right angles equal 90 degrees. That's just the definition of what a right angle is. Now they say A is parallel to B. How did we know that? Look back up here. That was given to us also. So they're putting another piece of given information in there. Yeah, you always like the given stuff. It's easy to, you don't have to think too much on it. Statement number 5, angle 1 is equal to angle 2. Why is that true? Well, 2 is actually right here, okay? It's kind of hard to tell from where I put it, but if you're looking at the book, you can see where angle 2 is. Those are corresponding angles, and basically if two lines parallel, and they are, A is parallel to B, then corresponding angles are congruent or equal. Okay. And again, a lot of geometry textbooks would say they're congruent and then say they were equal, but our book kind of plays loose with that a little bit. All right, if angle 1 is equal to angle 2, right here, and angle 1's 90 degrees, since they're equal, I know that angle 2 is equal to 90 degrees. And that's just substitution, or you could even put transitive property here if you wanted to. Either one of those would work. 7 says angle 2 is a right angle. Why is that true? That's the definition of what a right angle is. A 90-degree angle is a right angle. I'm just abbreviating here. And then the last step, 8, C is perpendicular to B. If two lines intersect in a right angle, then they're perpendicular. We had that way back when too. That's one of the reasons I've had you keep your proof book, is some of this stuff is going to go all the way back to, first chapter or something of the book. So it's the stuff, if you don't remember it, like I'm just kind of spouting it off here, you would be flipping through that proof book trying to find it. Okay, they're being funny with this diagram. If you notice all the letters, they spell the word pencil out. They tell us PE, in the figure below, if you're looking at number 8 through 12, PE is parallel to CI, and angle PEN is equal to angle CIL. Okay, so they're going to ask us some questions about this. They want to know, why is angle 1 equal to angle 3? Again, you don't have to write this down. I'm just writing it down. And why is angle 1 equal to angle 3? Well, if PE and CI are parallel, then those are corresponding angles. So those would be corresponding angles, or congruent, is why that's true. That goes back to all of our angle pairs from corresponding angles. Number 9 says, why is angle PEN equal to angle 1 plus angle 2? Well, that's because they make them up. What's that? Oh, gosh. That was called betweenness of rays, wasn't it? It took me a minute to remember it. That's the betweenness of rays theorem. Those are right next to each other. They share that middle ray. So that's the betweenness of rays theorem. That's why PEN is equal to angle 1 and angle 2. And it's also, if you look below it, it's also why CIL is equal to angle 3 and angle 4. It's the same reason on both of them, isn't it? Number 10, they want to know, why is angle 1 plus angle 2 equal angle 3 plus angle 4? Well, that's just substitution. Look over here. They told us over here that PEN is equal to CIL, and if so they're taking this statement and they're saying, well, instead of PEN, let's put in angle 1 plus angle 2 here, and then instead of CIL, since it's equal to 3 and 4, we'll put that down here and we'll make a new statement with it. They're doing a proof here. They're just, they're not telling you that's what they're doing. This is just substitution, isn't it? We just said those things were equal, so we substituted equal amounts. Now, number 11 says, why is angle 2 equal angle 4? Well, what did they do here? Look at the statement before it. 1 plus 2 equal 3 plus 4. Do you notice if you go back up at the top, they told you that angle 1, we already stated that angle 1 is equal to angle 3. So these two things are equal. Since they're equal, if I subtract them, then I'll be left with 2 is equal to 4. And since they're equal, I can just subtract them from both sides. And I'm subtracting an equal amount from both sides. That's just subtraction, isn't it? That's all they did there. Okay. And then on number 12, so why is EN then parallel to IL? Well, 2 and 4, if you go back over here and you look at where they are now corresponding angles, aren't they? And since corresponding angles are congruent, 2 and 4, the corresponding angles, then the lines are parallel that form them. The lines are parallel. Okay, so that was not too hard either. I'm going to skip to number 15 just because, problem number 13 is like some stuff we've done even on previous lessons, so it really shouldn't be that hard for you. If you're finding everything's too hard, then you may be depending way too much on help in class and videos, and you may not be doing much thinking for yourself, because by now this stuff should be getting a little bit easier. Okay, so in 15 we've got this diagram, and they tell us that we got some parallel lines here. This is parallel to this. When they put those little arrows on it, that's what that means. It means they're parallel. And they want to know what angle 1 is equal to, and they want to know what angle 2 is equal to. We're just trying to find all the missing angles. So here's what you can do if you don't see it. If I were to extend these parallel lines, do you see that this is a transversal right here? So 110 and angle 1 would be same side interior angles, and so they are supplementary. Remember that same side supplementary? So angle 1 would actually just, since they're supplementary, you would just subtract 110 from 180, and you'd get, oh, that angle 1 is 70 degrees. I'm going to write that in here. You know, likewise, I mean, there's a couple of different ways I could go at this, but let me darken this. Here's another transversal for those two red parallel lines. If this is 125 degrees right here, 125 and angle 2 are same side supplementary, so same side supplementary angles, so they're going to also be equal to 180 when I add them. So if I want to find angle 2, I can just say, oh, subtract that 125 from it, and that's going to be 55. I'm having trouble doing subtraction in my head. I believe it's 55 degrees. If I subtracted wrong, forgive me. Y'all can fix that on your own. You could use a calculator. 16 is a similar sort of thing. And if you notice, what was this? This was a trapezoid, wasn't it? Before we go on to 16. I just want to point out that this is a trapezoid. And on a trapezoid, you may not have everything congruent in here, but what you do know is that if they're on the same side of the trapezoidal figure, if they're along the leg, if you look at the leg of this trapezoid as a transversal, let me outline the trapezoid in yellow because just in case you don't see it, hopefully you do, there's the trapezoid. These two consecutive angles along that leg are supplementary. These two are supplementary, and then the other two over here were supplementary. So that's something that we now know when we go to study these figures in the next chapter. Because of parallel lines, you're already going to be able to know how to figure that out. And if you remember that those consecutive angles along that leg are supplementary, you won't have to go redo this every time if you just kind of remember that. That's kind of what they're hoping you're going to do, is remember this stuff. They don't make a big deal out of it like a lot of textbooks do. They just think, hey, you did that problem, you'll remember it now. 16, same sort of thing. You've got parallel lines here and here. They mark them with 2 to show that these are parallel to each other. And I'll just use some different colors here. Then they join them with 2 other parallel lines. So we're going to have all kinds of stuff going on here that's the same. They tell us that this is 70 degrees right here. And then they number some angles, 1, 2, and 3, and they want to know what are those angles. We just saw from the figure above, if we've got parallel lines in a transversal, then, you know, and if we have a couple of sets of those here. Let's look at this one. Here's 2 parallel lines. And if we look at this as our transversal, this blue line that I'm going to mark, angle 1 and 70 degrees are supplementary. So if I want to find angle 1, since they're same side interior angles, same side supplementary, they're supplementary, I can say 180 minus 70 degrees is going to be what angle 1 is, and that's 110 degrees. So I now know that's 110 degrees. Now, likewise, we got sets of parallel lines here, so this is pretty interesting. If I still look at those 2 yellow lines, well, now let me now look at the original green lines as being parallel, and I'm going to use a peach. These green lines are parallel. Let's make a peach line here as a transversal. If you look at the green lines as parallel and the peach line as a transversal, then angle 1 and 2 are same side interior angles. I didn't extend those green lines because this figure is going to get awfully messy if I keep doing that.